Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hardware to Save a Planet is brought to you by Synapse. Make sure to click subscribe so you don't miss any future episodes. Thanks for listening. Hello and welcome to a special end-of-year episode of Hardware to Save a Planet. As we wrap up 2024, I'm reflecting that while the process of making this show has given me a ton of optimism, I also want to acknowledge that there are a number of things happening right now in the world that are reminding us just how massive this climate change challenge is. 2024 has been the hottest year on record, and it looks like the global average temperature will show that we've warmed Earth by more than 1.5 degrees C since the 19th century. That's the threshold that was set by the 2015 Paris Agreement. It doesn't mean we've breached the agreement because the agreement refers to a 20-year average, but it's a troubling bar to surpass regardless. We've also seen more extreme weather events like flooding, hurricanes, and landslides, which have taken thousands of lives. In the US, we had 24 weather-related disasters that cost more than $1 billion each, which is the second highest year for that stat on record. In the US, we also have a new administration starting in January, and regardless of your politics, most believe this could result in a reversal of some of the climate policy progress we've made recently. And I don't want to be a wet blanket, but I do think it can be constructive to have awareness of the challenges and our struggles so far to meet them. I think it can be really helpful for driving the kind of ambition we need to face what's probably the hardest thing humanity has ever set out to do. And that intense ambition in the face of a real understanding of the challenge is what I think inspires me most about the guests we've had on this show. Despite knowing what they're up against, they still envision a better world and are dedicated like crazy to make it happen. So if you're new to the show, I hope you'll scroll through our backlog and listen to these incredible stories in more depth. But for this episode, we've picked out a handful of highlights from the year to share some valuable insights and help to illustrate that ambition. The first one is from Robin Langtry, co-founder and CEO of Avalanche Energy. Robin and his team are rethinking fusion energy with a bold, unconventional approach, developing small reactors roughly the size of a microwave. Developing fusion is an incredibly ambitious mission that has the potential to revolutionize the energy landscape with abundant, cheap, and clean power. In this clip, Robin discusses the critical role fusion can play in tackling the hard-to decarbonize industries. So let's say we get to this Q engineering state with fusion. We have fusion reactors that can power themselves, and we have very cheap, abundant, clean energy. What's the significance of that to the world? How does that change things?
Yeah, so like right now we're in the process of doing all this sort of low-hanging fruit for clean energy, right? Like solar is scaling massively every year. Wind is scaling. We're electrifying the automobile industry, right? We're doing what I would call the low-hanging fruit, the easy stuff. Well, it's not easy, but relatively easy. We are going to get to the point where there is no more low-hanging fruit, and we're going to have to decarbonize really hard industries that require a lot of energy.
Next is Alicia Fredrickson, co-founder and CEO of Seabound. She and her team have an approach to address maritime emissions today with existing fleets via onboard carbon capture. She explains some of the challenges of decarbonizing the maritime industry with carbon-neutral fuels today. Why is that? Why is it so far out that those fuels will be available at scale?
Yeah. I mean, I think like shipping is really, really hard to abate for, a number of different reasons, but I think one of them is the willingness to pay. And so I think it's kind of mostly a market-based answer in the sense that, running a ship on carbon neutral fuel is more expensive than running a ship on conventional fossil fuels. And there are new regulations that are starting to change the equation a little bit, but not yet to a meaningful degree such that there is a lot of urgent action and change. But I think, so shipping entered the emissions trading scheme in the EU this year. And so that currently I think is about 70 euros per ton. And it's phasing in. So not all of the emissions for ships are subject to that penalty today, but over time they will be. But I think there's estimates that it would need to be at around maybe 200, maybe 300 or more euros per ton of CO2 emitted in order to actually sort of tip the scale in the favor of carbon neutral fuels. So I think that's the tough part, is that it's too expensive, really. And therefore, it's hard to secure offtake agreements to start to develop the facilities to produce these fuels.
Next is Rory Brogan, founder and CEO of Torev Motors. Rory has developed a more sustainable electric motor design with a reduced reliance on rare earth metals. Here, Rory explains how Torev's innovative design enhances power density, extends battery life, and even boosts safety for industries like aerospace. He also shares why economic impact is key to scaling climate tech and how sustainability can be the cherry on top of a compelling business case. When I first learned about what you're doing in Torev, what I picked up on was that the big advantage of your motor is the reduced use of rare earth metals. Is that the right way to characterize it? Is that kind of the main selling point?
It's one of them. In the world of electric motors, what we realized pretty quickly is that everyone and their mother is trying to create a motor with less rare earths or no rare earths or whatever percentage of rare earths you really want to put in there. And so it's certainly an advantage. It's a selling point when it comes to cost for us. But at the end of the day, we are, as any climate company is, right, we're subject to what we've been told is the Mr. Burns test, which is, this is great, you can reduce rare earths, you've got a good environmental impact, that's all wonderful. Why do I care? Why should I buy this thing? At the end of the day, you need to have that economic impact, right? And that is certainly helped by our reduction in rare earth metals. But where the real selling point comes from for this device is from what's referred to as a power density. You're able to get a lot of power from a very, very small packaging. You're able to achieve this very unique, what we refer to as a dual operating mode, that just allows you a lot more control over the power going into your motor and what's ultimately coming out of your motor. And it just allows for a much easier way to extend battery life, to achieve a direct drive, to get gearboxes out of the way if you're looking at electric vehicles. There's a host of frankly, even right before this, we were talking to an aerospace company, and one of the things they were pointing out right off the bat was, hey, 2 coils, extra redundancy. And when you're starting to look at electrification of aviation, right, you start looking at failure in motors, you need to be able to provide that level of redundancy. And so it depends a lot, honestly, on who we're talking to, what the real advantage is. But the nice thing that we get to point to for all of them is that there is a more sustainable solution. It's just more of a cherry on top, as opposed to the full selling point of the device.
This next clip is from Daniel White, co-founder and CEO of Clean Crop Technologies, with an approach to improve the efficiency and efficacy of our food systems. Their innovative plasma seed treatment technology boosts yields, reduces waste, and cuts greenhouse gas emissions. Here, Daniel shares how global climate challenges, from shifting rains to extreme weather, impact growers, and highlights the need to help farmers buffer against these risks. Do you feel like your kind of perspective on climate change and agriculture and just what problems are important to be focused on was influenced really differently by all this global exposure than it would have been had you stayed in the US?
Yeah, I think definitely seeing how climate change is creating very different problems in different parts of the world was really illuminating. So in some of the parts of East Africa where I worked, one of the biggest challenges they're running into is just shifting rains. And when you're in a lot of these tropical and subtropical climates, particularly with working with farmers without a lot of access to electricity or irrigation, the rain seasons are everything for the food security in those areas. and seeing how the impacts are different in places where those rains are getting more and more sparse, like has been happening in large parts of Kenya, versus other areas in Tanzania where the rains are getting more intense. And obviously it varies year over year. But seeing how the biggest impact there is not really structurally one or the other. Over a 10-year period, they're probably experiencing not a huge difference in total rainfall, but it's the increased volatility. And I think that's really been the biggest thing and the most alarming thing to me when I look across the different parts of the food system where I've worked is the planet macro level is getting warmer. In theory, on paper, where there's more parts of the world where you could grow for longer, right? So there's all these studies looking at how there's now parts of Canada where you could be growing crops that 10 years ago by the temperature you wouldn't be able to. And in some places that's true, but in a lot of places that's still not true because you have this increased frequency of these really extreme conditions, which really outweigh a lot of the potential benefits from theoretical increase in like the temperate growing zones. And I think you see how that plays out differently in different parts of the world in a way that shows that the fundamental thing we need to be doing for our food system today, more than trying to mitigate the impact of agriculture on climate change, is recognizing that the die is cast. And the biggest thing we can be doing is trying to help growers find ways to buffer against those climate risks one way or the other, and help them provide some training wheels or some factors of safety on that production any given year when they're going to see more drought, they're going to see more intensive rains, they're going to see heat spikes and cold snaps. All of these are part of climate change as experienced by growers. And really from the technology and the innovation side, we need to be focused on ways to help blunt those particular extreme events if we're going to preserve and expand food production the way we need to.
Next up is Natasha Kostanuk, founder and CEO of Ayrton Energy, a company tackling two of hydrogen's biggest challenges, storage and transportation. With their liquid organic hydrogen carrier technology, Natasha and her team make hydrogen as easy to move as diesel, thereby improving its potential to decarbonize hard-to-abate sectors. In this clip, Natasha explains why hydrogen is essential alongside electrification and how it can help bridge the gaps in our energy infrastructure. Why is it hydrogen instead of electricity electrifying some of these really hard-to-abate sectors we talk about? And is it about generating heat? And then if that's the case, why can't we generate that heat with electricity? Why the focus on hydrogen?
Yeah, and I'm definitely not one of those, founders that's going to be like, everything needs to be hydrogen. I do believe we need a balance, and I think we need electrification, and I think we need, other things like hydrogen. But electrification is really hard. It's the infrastructure. It's not built to handle this electrify everything shift that we're doing. The infrastructure, if you read some of the studies, they say that it's billions and billions and billions of dollars of infrastructure upgrades that need to happen, in addition to all the billions of dollars in generation that need to happen. And moving and upgrading that, like moving energy with electrons and adding that infrastructure is just very expensive and very difficult to today's existing infrastructure systems. The densely populated areas that need all that energy, it's very hard to upgrade and make changes to that. So it's going to happen. Like some of it will be upgraded, and there is some upgrading happen, but it cannot meet all of the needs. There's going to be a gap, and that's where we think hydrogen can play a part in filling that gap.
Next is Michael Rigney, CEO and co-founder of Kala Systems, with an intelligent heat pump water heater designed to reduce residential energy use and emissions. With water heating responsible for 19% of home energy use and 3% of U.S. greenhouse gas emissions, Kala's innovative solution could have a big impact. Michael shares his approach to scaling a climate startup, emphasizing focus, persistence, and the long-term potential to decarbonize all 125 million water heaters in the U.S. From a business perspective, you just talked about kind of starting to enter this commercialization phase. In a lot of ways, those incumbents have, a big head start, right? They have their distribution channels, everything. How do you, as a startup, how do you go up against that? Because I imagine to have the kind of impact you want, you're going to have to scale to a pretty significant level, right? How are you approaching that?
Focus and one step at a time, right? And so I think, this is, maybe this is where, for me personally, Enernoc played a significant role. So we touched upon that before for listeners. There was a demand response company that was founded in 2002. It went public in 2007. And so, when a business startup gets traction, you can scale really rapidly, but it's a decade-long journey. And so it's focus on what you're doing, execute one step at a time, and expect for it to be a long journey, right? And that's exactly how we think about it, is to keep just an even keel, do the work every day, but recognize that the promise is there. Because, ultimately, there are 125 million water heaters, in America. And if we're able to realize our vision, then not just through our own sales, but through influencing the industry, because that is what happens with startups, right? Over time, we can drive the decarbonization of all 125 million of those. And I think that's both promising and a long journey, and exciting to go after along the way.
This next one is from Kemp Gregory, co-founder and CEO of Renewal Energy. They're repurposing idle oil and gas wells for gravity-based energy storage. I love the efficiency inherent in this creative way to reuse existing infrastructure. In this clip, Kemp addresses concerns about collaborating with oil and gas companies, emphasizing the importance of reusing what's already built to accelerate decarbonization. Do you get any pushback from the kind of climate investing community or climate community for working with oil and gas companies?
Every once in a while, I'll get a VC that's just like, no, this is too oil and gas adjacent, or no, you're helping an oil and gas company, therefore we can't work with you. I would say that's the minority by a pretty large degree, which is nice. Most of the VC community, I think, well, they want to make money, but also they get that rebuilding everything from scratch is a crazy town notion. It's just not going to work. You know that the United States has like hundreds of thousands of miles of oil pipelines and natural gas pipelines and roads and electrical infrastructure. We should be repurposing as much as we possibly can. That's where we should start. And in an ideal world, you not only repurpose that infrastructure, you get paid to repurpose the infrastructure. That's what Renewal is. We create an economic incentive for the oil and gas companies to pay us to convert those wells. We create an economic incentive for the oil and gas companies to pay us to convert those wells.
Next is Chris Tolles, co-founder and CEO of Yardstick, a company revolutionizing soil carbon measurement to drive climate-positive agriculture. By reducing the cost of high-quality soil organic carbon measurement by over 90%, Yardstick unlocks opportunities to restore soil health, improve farmer livelihoods, and combat climate change. In this conversation, Chris shares the challenges of making a measurement device like this work in the real world. What's challenging about your hardware? How has that process gone? I'm curious kind of how mature the hardware is, and what kind of physical engineering challenges you've had to overcome to get to where you're at.
One of the biggest challenges is the variability of soils. It's infinite. People often use the metaphor of human populations and variability in humans, but there's way more variability in soils than there are in humans. Moisture content, texture, parent material, actual terrain, right? Measuring soil carbon on flat as a board, 40 acres in Iowa is completely different from 75,000 acre ranch in the middle of nowhere, Montana, where there's a river in the middle of it, Durability is challenging, right? This is a field instrument. And so invariably it's just going to get tossed in the back of some ATV. So how do you have both precision and rough and readiness? Spectroscopy is a pretty mature discipline, but it's dominated by academics. And so the way to think about Yardstick's hardware is when you buy a DSLR from Canon, the sensor inside it is made by probably some Taiwanese firm. And the sensor is not the camera, right? Canon had to do an insane amount of work to make a good camera. It's the same thing. Our spectrometer is actually commercial off the shelf, which is good. One does not want to design a custom spectrometer. That's a totally different discipline and enormously difficult and expensive. But Canon, 30 years ago was buying commercial off the shelf sensors for digital cameras and being like, wow, I got a sensor, but like, I do not have a camera. And so it's the same engineering barrier of like, how do you take a component and embody it in a hardware, in a piece of hardware that can actually do the job? We need reference scanning. Spectrometers drift. We have an internal shutter that needs to be actuated. We need it to be wireless and handheld and durable. You'll see in the video, it's powered by the same drill batteries that power the drill. We use an off-the-shelf drill because Makita has spent, probably $1 billion of engineering on the drill. We should probably not try and redo the drill. So that's really the central mechanical challenge, is taking this ostensibly mature sensor and putting it in a package that actually results in the thing we're trying to do. And even once you get the hardware performing well, you have to train it on soils. And so the data collection aspect of this is very challenging because it has to come from, various farms and ranches, which means you need to go there. That's why you see so many of these companies that'll tell you they can measure soil carbon from outer space, because it's just like, it's really easy to deploy a piece of software if you don't have to go there. Soil carbon's underground. So like satellites can't see under there. That's why we focus on the proximal piece of the equation. But even when our instrument is working exceptionally well, you still have the calibration complexity of, cool, spinning up a new customer. I was talking to somebody in Ireland earlier today. And they're like, how much of your library is Ireland? And I'm like, 0. And so now we're getting into just the unit economics of like, where do we collect training data? What regions do we prioritize? What crop types do we prioritize? How do we spin up new regions with calibrations that are transferable? The data science aspect of our hardware is as significant, if not more significant, a challenge than the actual mechanical dimensions of what we're doing.
This one's from Adam Root, founder of Matter. Adam and his team are tackling microplastic pollution at the source. Every wash cycle of our washing machines releases up to 700,000 microfibers that eventually enter our oceans. This harms biodiversity and enters our food and water. Matter's approach captures these microplastics before they escape and can then recycle them. With a strong engineering team and a vision for expanding applications, Adam shares insights on scaling solutions from washing machines to wastewater treatment plants, driving sustainability and circularity. On the technical side, you're an engineer, you've been through this product cycle and product development process a bunch. Do you feel like there are technical engineering challenges ahead of you, or have you mostly retired a lot of that risk?
We're as a business, we're in a late stage technology development piece with one application. There will be more technical development challenges as we move into different phases. Moving from washing machines to wastewater treatment plants. People look at me and go, "God, you're crazy. What are you doing?" They're really different. For me, I just see it as fluids. We worked out the mechanism of fluid, the way that works. And then we scaled it up and it did exactly the same as what it did at the small space. So, but there is risk that you've got to, build something super robust, and there's something you don't think about. I've got a really strong engineering team, and I'm really fortunate that they really know what they're doing. So I think, that's something that I'm less concerned about, but I think what I think is really fun is what the next innovation is out of this business. Where that looks, and I don't know where that is yet. We've got a couple of really cool ideas that we're working on, but I think the technology development we've done so far has been on a shoestring budget, and we just started really opening up our fundraising. We really started kind of doubling down on building a team out. These guys need a bit of time, but the stuff that's coming out the other end at the minute is just unbelievable and significantly better than what I ever designed. So I'm pretty excited about that.
The last clip is from Oliver Gunasekra, co-founder and CEO of Impossible Metals. a company focused on mining the seafloor for the metals we'll need in the energy transition. They do this with underwater robots that collect metallic nodules at the bottom of the ocean without damaging marine ecosystems. Oliver shares his approach to tackling controversial issues, balancing innovation with responsibility, and inspiring entrepreneurs to embrace the bold, science-grounded solutions to global challenges.
What advice do you have for someone not working in climate today who wants to do something to help?
Just do it. I mean, it's, you can make a lot of money, working for an app store or a social media company or whatever. But I think, as you get older, you should think about legacy, thinking about combining your skills with doing something good. One thing I'll touch on is that we set our company up as a B corporation. So that's a public benefit. So it means that we are a for-profit, but we have a legal obligation, our directors do, to balance the needs of our shareholders, but also to do the public benefit that we stated on our certificate of incorporation, which for us is delivering responsible critical metals, to help mitigate the climate crisis. So it fits together. And I think it's incredibly rewarding, and it becomes a lot easier to attract talent when people feel that the mission of the company is aligned with the health of the planet. And there are huge financial rewards and huge technical problems to solve. And in my experience, the best people kind of want all three. They want to feel that they're doing right for the planet and its people. They want to solve really difficult technical problems, and they want to be able to be personally successful if the company's successful, but there's big potential return. And I think, climate tech can offer all three. So go and do it. And doesn't matter what your skill set is, there's opportunities out there, and there's so many people now trying to come up with solutions. Just join with them and make it happen.
Thanks for listening in. I hope this helps you both wrap your head around the enormity of the challenges we face, while also giving you some optimism from seeing the ambition fueling the people developing these solutions. Hit subscribe and keep an eye out for some really exciting new guests in 2025.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.